Alright, so we are going to solve a one-step variable equation. Solving equations with variables means you're trying to figure out what the value of that variable is. And these are going to be one-step problems where you basically get one step and you're done. The last one will be a little bit different, but I'll explain why. So I have x plus 2 equals 7. It's probably can figure this out without actually doing the algebra. You can probably think, well, I know 5 plus 2 equals 7. But we're going to go and see how would you solve this if you didn't know that. And I'm going to draw a picture of this first so that way we can see a visual. Here's my x. I'm not really sure how much that is. And then I have two little circles. And then that is equal to 7 over here. So I'm going to write that right there. And I'm going to rewrite this over here. X, wrong color. X plus 2, x plus 2 equals 7. Now, what I want to do is I want to get x all by itself, because if I can get x all by itself, then I'll know the value of x. And so the way I'm going to do that is I'm going to see what's next to x. On this side of the equation sign, I have plus 2 with the x. So to get rid of that plus 2, I'm going to have to do the inverse operation. Instead of adding 2, I'm going to have to subtract 2. So I'm going to say subtract 2, and then my picture, that would be like doing this right here. And then I have my x by myself, because plus 2 and then minus 2 gives you 0, adds to 0. But if I just left it at that, what would happen with my little seesaw over here was this side that has 7, 1, 2, 3, 4, 5, 6, 7, ends up being a lot heavier than the side with the x, because I just took 2 away and they were even. But now it's lighter, it's less. They're not even anymore. They're not balanced. This equal sign says they need to stay balanced. So I can't do this. Let me get rid of this. I can't just get rid of things and not do anything on the other side. I need to keep things balanced. So I'm going to say 7 minus 2. And over here I'm just going to cross 2 of these out. And if you notice, I'll have 5 left over. The way I would write this side ends up equaling 5. A lot of people will be like, oh, the 2's cancel out. I don't like saying the 2's cancel out. I rather say they add to 0. X plus 0 equals 5. You don't have to write x plus 0 because it's still just going to be equal x, because the additive identity says adding 0 to something keeps the identity. But I do want you to know you're just not just crossing these out. These things are adding to 0, and then you end up with x equals 5. The value of x is 5. Let's see another example. So here I have x minus 3 equals 4. If I want to draw a visual of this, I'm going to have to draw my x on this side. And I'm taking 3 away. So I could draw this a couple different ways. I could just say cross these out. Those are 3 that's taken away from x. And then on this side I'll have 4. 1, 2, 3, 4. Right now they're balanced. They're equal. So I need to get x all by itself. And so if I have a minus 3 on this side, the inverse operation of subtraction, the inverse operation of minus, is addition. So what I'm going to do is I'm going to add 3 to this side. Let me do a different color. Let's do green. Adding 3 to this side. And so that's like saying, okay, the 3 that I got rid of, I'm now adding them back. But now this side is heavier. This side is more. This has more value to it. And so if I add 3 to this side, that means I'm going to have to add 3 to this side to make sure that they stay balanced. Okay? And then that gives me x minus negative 3 plus positive 3 ends up adding to 0. And then 4 plus 3 gives me 7. I don't have to write x plus 0. I'm just showing you that these add up to 0. You're not just crossing them out or getting rid of them. But you can write this as x equals 7. This little value of x is 7 right here. So let's see one more problem. Alright, so this one's going to be a little bit different. We have 12 minus x. And the way we can, let's draw that real quick. We've got 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then on this side I have 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm not adding x to this. I can't just say x right here like that. I'm actually subtracting x. So I'm going to show that with that little line. It's been taken away, and now these are balanced. So this is a positive 12, even though it doesn't say positive. There's not a negative sign, so we assume it's positive. If I need to get x by itself, I need to get rid of this 12. I need to balance these sides out. The way that I'm going to do that is I'm going to show, I'm going to take 12 away, because if this is a positive 12, the inverse operation would be negative or subtraction. And then I'm going to have to take 12 away from here. So 12, positive 12 plus negative 12 ends up giving me 0. 0 minus x. And on this side, 10 minus 12 gives me a negative 2. Let's do, I guess we can do purple with that. Negative 2. So if I did this on my picture, I can rewrite this as negative x equals negative 2. If I did this on my picture, the way I would show that is I would first get rid of the 12 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Get rid of 12 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I need to get rid of 2 more. They're not there, so that means it's showing this is representing negative 2. So if I redrew that like this, I have, to keep them balanced, I have a negative x, an x that has been crossed out, and then I have a negative 2. Now I am not actually done solving this, because I don't want a negative x, I want a positive x. But the way that you can look at this so that it's a positive number, we can use some of our operations. Negative x, to turn that into a positive x, I need to multiply it by negative 1. Whenever I do on one side, I have to do the other side to make sure they stay balanced. Negative 1 times negative x. Negative 1, I shouldn't do it like that. Negative 1 times negative x. If you remember, a negative times a negative gives me a positive. And anything times 1 is itself. So negative times a negative gives me positive x. I'm going to rewrite that as a positive x right here. Positive x equals, I have a negative 2 times a negative 1, and that gives me a positive 2. Positive 2. And so to show that, it's kind of hard to show that because you can't really, how do you show multiplying by negative 1? But you can just kind of show the result of it, the inverse. After you multiply by negative 1, you end up getting a positive x and a positive 2 right here in your picture. It's kind of hard to show that, but that's how you would, if you end up getting a negative x there, that's, you just multiply both sides by negative 1 to make sure that your result is positive. So give the practice problems a shot and let me know if you have any questions at all.